Okay, so that brings us to 11.5, revisiting the list exercises from week 5. Oh joy, we're doing exercise 5. Okay, that's great. But we're doing it with NumPy, so we can maybe simplify it a little bit. So we have some functions that we need to do here, and it'll turn out that these functions are pretty. You can implement them a little bit faster with NumPy than maybe we could in exercise 5. So we need to work in this Python file. So let's find it. Not 9, not 10, 11. Here we go. So a lot of functions. Good. Quit, of course. It's not quit. It's clear. It's quit. Okay, fine. So now we're quitted. So we can see that these functions take empty arrays as input, and in some cases some other numbers, and then they need to return, I guess, numbers or empty arrays in general. Yeah, so that's what they need to do. So I'm going to experiment a little here. So I'll define a NumPy array. Let's just select the random one, like this, -1 through 9, 4, 16. That is a fine array. And then let's see, the first one needs to compute the average. So let's compute the average of B. And we'll just print it out. Okay. So how do we do that? Well, the NumPy array is called. Let me just insert a breakpoint. I think we'll approach it like this. So now I insert a little bit of a test down here, just calling the function with this array, and I inserted a breakpoint up here, and I put in a number here because I need a line to put a breakpoint on. I cannot put it on a comment, unfortunately. So if I do that and I start the debugger, it's basically going to read the file, read, call the function down here, start running the function, and then it hits the breakpoint and stop. And that will allow me to do my usual trick, going in and looking at what the data is and coming up with an idea. In this case, my idea is to remember what I said a moment ago. There is a mean function. So I can just use the mean function and then return data.mean. And in order to speed things up, I'm just going to plug in breakpoints in all of them. There, oops, needs to be indented correctly. Yes. Oh, breakpoint. Why? You don't want to be a breakpoint. Breakpoint. We will add a little bit of line spacing. This. Okay, so that was the first one. Let's look at the next one. Conditional maximum. Returns the maximum value of an array that is smaller than the threshold. Okay, that sounds like conditional max. So the elements that are smaller than a threshold, I guess we select the threshold of 4. Smaller than or equal? I guess it's smaller than, so it's strictly smaller than. Okay, fine. Let's stop the debugger because I changed the file, run it again, and now we're going to hit this breakpoint and we can start to look at the problem. So data is in this case this array, and threshold is 4. So first we need to figure out how we compute maximum values of an empty array. Well, there is a sum, there is a mean, there is a size, there is a shape. Maybe we are so fortunate there is a max, and there is. So the maximum, we select the maximum. Since there is a max, there's also a min, but we'll use the max. So this can give us a maximum of an array. Now we need the right array to create a maximum of. So we want to get the array, the maximum of the array that is smaller than the threshold. So we need to get that array. So we can do that using indexing. So if I do data less than the threshold, I get an index list. and then I can get the array of the elements that are less than 3. These are these ones, and then I can just do max of that, and that gives me 3. That seems reasonable. So all I need to do here is probably just to return that. Okay. Maybe now is a good time to look at some of the tests. Yeah, I messed that one up. Week 5. It's good that we're redoing it. Threshold. Is that the right one? No. Outliers, list. Is that the right one? Yeah, okay, I guess that's the right one. So let's see if average is correct. It is. Let's check this one. It is. Oh, yeah, fine. So let's go on. Vector add. 2 arrays, compute the sum. Okay. We are not going to do that in the debug. We can just add them together. Count multiplies. Count the number of multiples of a number in an array. Okay. So in order to make this a little more pedagogical, I'm going to add a couple that are multiplies of 5. So 10 and 15. Good. So now we call this function count multiples, and we give it this array, and then maybe we do it with 5. I think I spelled it wrong. Count multiples. Okay, fine. So return multiples count. Okay. Fine. Let's do debug. So we call the example, and the debugger will call the function, and we will end up here. So let's look at data. That's this, and divisor. It's what is called this 5. Count the number of multiples. So how do we check that something is a multiple of another thing? We can do that with the modulo function, which we've seen a couple of times. So the modulo function gives the remainder by division. So if I do data modulo divisor, it tells me the remainder by division, where the remainder of each element when I divide by divisor. So divisor in this case was 5, and that means that the remainder here is 2, the remainder here is 3, and the remainder in 15 is 0, because 15 is divisible by 5, and so on and so forth. So 16 is 1, and 10 is also 0. So now I need to figure out how many of these are equal to 0. So there are a couple of different ways of doing that. I could see how many of these are equal to 0, like this, and then I can do sum, and what sum will do is that it will count false as zeros and trues as 1. So it will add the number of trues together, 1 plus 1. So this is actually going to do 2. So maybe this is a little bit cheating because I'm using something that I knew about adding false and true together, but I think it's fair. It's a short way of solving it, and I think the alternatives are about as confusing as this. So let's return that. So this is one way of doing it. The alternative way of doing it would be that you, and let's just do that. So if I check which ones are equal to 0, what I could maybe do is I could select the elements of data where this is true, and then I could do the size. And this would maybe be a way of doing it where I only use things that we have, strictly speaking, seen before. But I would probably prefer to do the solution that I have here. I think this is slightly more direct. But now that I have done what I just did down here, this actually solves the next problem, right? Because in the next problem, I need to return the multiples of a number in an array. and that means the cases where the division by that number is equal to 0, then it's a multiple, and this will exactly do it. So actually, just do a little bit of copy paste here. So again, hopefully these examples convince us that there are situations like where NumPy operations are really fast way of accomplishing things where we needed to write some loops last time. Let's see, add. I really hope I didn't get this one wrong. That would be a little bit embarrassing. And these seem to work as well. Cool. So I think I'll end here. Ooh. Yeah, cool. I think I'll end here, and then we'll go to 11.6.